Hello everyone, I'm Shafiq and currently I'm a senior lecturer at the Department of Structure and Materials, University of Technology, Malaysia. So it is my great honor to be here for the application of physics in mechanicals and materials engineering 2024. So I'm here to give a talk on the recent developments of phase change materials, PCM, in the building structures. So before we go deeper, so this is the outline of my talk. So I will explain about the climate change and also the definition of these phase change materials and also its behavior and potential application, how we can incorporate these PCMs as one of the component in the building structures. So climate change, so we know that this is a major concern, not only in Malaysia, but throughout the world. So we are having this kind of problem, which is a climate change. We are having the problems of heat wave problems, depletion of the ozone layer, maybe the melting of the glaciers, drought problems. Okay, so this is a major concern that we need to minimize and, if possible, we need to overcome. So the International Energy Agency, so they have reported that these buildings is responsible for almost 40% of the final energy use and also the CO2 emissions. That's mean the total CO2 emissions. Okay, so it is the most critical sectors, okay, for in terms of the energy consumption. So inside the building, we are using a lot of energies, and it is very important for us to applying this passive system which we can apply by implementing these phase change materials, okay, to meet the net zero carbon emission by 2050. So I have been done and still doing research on the phase change materials, maybe for the past 6 to 7 years. Okay, so one of the reason why I'm focusing into this vintage materials is because of the heat wave problem that strike my country, which is Malaysia. So we are having this heat wave problem for the past 10 years. Okay, even though Malaysia is having a rainy and hot days, okay, throughout the years, okay, but for the past 10 years we are having this heat wave problems, usually in the middle of April and May. So you can see that it is not only strike Malaysia, but it strikes India, Bangladesh, China, Thailand, especially in the Southeast Asian country. So if we're having this kind of heat wave problem, of course we are we have to drinking a lot of water. And then if we are inside our home, okay, so we will use a lot of electricity. Okay, the electricity consumption will be very high because we will use a lot of air conditioning, right? So to make our body very comfortable inside the buildings. So one of the way how we can minimize this kind of consumption, electricity consumptions, and how we can improve the comfortability of ourselves inside the home is by applying this phase change material. So these phase change materials, okay, can be divided into three categories. So you see here we have organics, which is divided into paraffin or non-paraffin. Okay, so non-paraffin we can have a fatty acid as the alcohols or glycols, and if the phase material is in organics material, so we can have a salt hydride type and also metallics. And if we are having a eutectic, which is a combination of organics with organics or inorganics with organics, okay, we can have this eutectic type of PCMs. So basically, this PCM, okay, so this PCM have the ability to absorb heat energy. Okay, so during the day, it can absorb the heat energy and it can turn, let's say the PCM is in solid form, it can turn to liquids. And then during the night, it will release back, okay, when the temperature falls, it will release back the heat energy and then it will be solidified. And then the next day, it will melt it again. and then at night it will solidify. So this PCM can sustain in the long term. That means it can be used for a long-term application, uh, especially in the building structures. So, however, the implementation of these fixed materials inside the building structure have a huge problem, which is a leakage problems. So let's say if we directly use this PCM, okay, it will enhance the corrosion and also it will react with the hydrated phases if you directly mix this PCM with cement. So one of the solution, okay, some of the solution that can be used is by applying the encapsulation method. So there is a lot of type of encapsulation methods that we can do. One of the way is we synthesize these macro size encapsulated materials. So the inside material, which is a core materials, will be the PCM, and the outside materials can be any organic or inorganic materials that we can use. Okay, and then we can also have a nano size, which is smaller size of the encapsulated PCM. And then we can have also macro encapsulated PCM, which is in a bigger size. So one of the way we can use this techniques is by put it the PCM inside the bricks. Let's say in this figure. So inside the brick there is a hollow. Okay? We can we can incorporating this PCM inside this hollow section of the bricks. And then the next one of the way we can use is as a wall panel. So we can incorporate this PCM as a wall panel. And one of the way that we can incorporate it is by using a pipe encapsulator, which is mainly we have a pipe, hollow pipe, and then inside the hollow pipe we will incorporate these three-stage materials, and then it can be one of the components in the building structures. Okay, and then next is a shape stabilized PCM, which is you have a biomass, and then you have to turn the biomass into biochar, which should have a high pore structure. So you have to do some activation to activate the pore structures, and then inside the pore structures, we can impregnate the phase change materials. So the behavior of this PCM inside the cementitious system. So this is one of the study which is they have used Portland cement with the microencapsulated PCM. So they have added using a various amount of PCMs to the reference mortar, and they have concluded that there is no interaction. That means they say that the PCM, if they leak, it will not interact with the hydrogen products. However, if you have added 15%, that means if you added PCM into the cementitious system, it will increase the porosity of the composite. So if you mean that if you have the increase in porosity, of course you will have the reduction in the mechanical performance and also the durability. And this is some of the study where they have used LC3 cement with a microencapsulated PCM. You can see here the pore structure increasing. And some of the study that they are focusing on calcium sulfur aluminate cement with a PCM. Okay, so they have concluded that the addition of this PCM will reduce the compressive strength, and also it will reduce the total porosity with the presence of these PCMs. And also this PCM can be used as a 3D printing technologies where if you are using a PCM, it can decrease the hardening evolution over time, and also it can result to reduction in mechanical strength. So we know that this PCM, if you are directly incorporated inside the cementitious system, it will give a lot of problem, especially on the mechanical performance. So there is a still huge gap to be filled in this area, especially how we can minimize or how we can reduce these strength reductions if we are applying this PCM inside the concrete structures. And so this is some of the study that I have done. So when we are incorporating this nano size PCM, okay, there is a active bubbles coming out during the mixing process. We can have these active bubbles which can lead to very high porosity of the uh, composites. So some of the application of the PCM, okay, not only you can mix inside the concretes. So one of the way is it can be used as a dry floor heating system. So this is the study that has been done in South Korea, which is are having a it's a four season country. So they are applying this PCM as a dry floor heating system, especially it is a very efficient, especially in the winter season. And then this PCM can also be used to improve the energy efficiency of the building structures. You can see here that they are utilizing the macro encapsulated PCM. You can see that the temperature, that's mean the maximum temperature and also the minimum temperature when they're applying the macro encapsulated PCM, it can reduce the energy consumption and also it can reduce the diffusion of the heat to the building. So as a conclusion that yeah, this PCM can use is a very uh, unique material that we can use inside the building structure, how we can improve the thermal comfort of the building. So however, by adding PCM into the concretes, it will reduce its mechanical performance. So that's why I'm saying that in this part there is a huge gap that we need to fill. How we can adding this PCM without changing its mechanical. That's mean without changing its or without reducing its strength performance. And also, of course, by adding high quantity of PCM is a very huge challenges. That's mean if yeah, we can add it by using a macro encapsulated techniques, but it is very important also if we can add it the PCM by using other techniques like shape stabilized, micro encapsulated or nano encapsulated materials. And also these pre-change materials can be utilized for a wide range of application, not only building structure. You can use as a in the solar energy application, you can use in the medical application. So there is a huge potential for other application also, not only in a, as a not only can be used in the building, but also for other application because of its unique uh, behavior to absorb heat energy and also release it back. So I think that's all for me. So if you have any question or if you have anything to ask, please feel free to email to me. I think that's all for today. Thank you.